This is part 2 of multiple regression, and we are covering the Quinta Inn example. So I will go directly to the question that we left last time, which is we obtained the regression equation previously. So we got to the point that y bar equals 19.317 plus 1.3004 times x2 plus 0.0219 times x3 plus 0.0350 times x5. And just to remember, this is given in the last table of the multiple regression. So the next question that we need to follow, and notice I'm in all this part I'm following the procedure in regression. That's not a given procedure, but it's just a study tool. And we we determine, we're in this step, we determine the regression equation. I'm sorry, I cannot see that. We just determined the regression equation, and now we want to see the estimation of beta for a requested xi. So remember that when we started running regression, we said we need to check to see if there's any question referring to the slope of any of the variables. And we noticed that we had question 5, estimate with 94% confidence level the slope for household income. Since we indicated 94%, then my Excel output, notice that the last table sorry, the last table will have lower and upper 94%. If you don't indicate that, the 95% will always repeat twice. So we have the 95% confidence interval and the 94% confidence interval for all the slopes, but we're just asked for the income slope. So all you had to do really, if you indicated 94 in the data analysis regression, then all you have to do is copy those values. But what if you are given the data like a summary ANOVA with no data, original data, where you cannot run regression? Then that's where you use the formula given in the template, where BI equals B1, that's the intercept from the regression, plus minus T of alpha halves, comma, degrees of freedom from the residual, times SB. So I want to make sure that you know where to go and get all those values. B1 is the intercept for income. So we go into the last table in regression and look for the coefficient of income, 0.035. That would be my B1, or B5 in this case. Then we follow the formula T inverse of alpha halves times 2, because every time we have T in front of a plus minus, it's a confidence interval, and that's a one tail. So we have to always multiply by 2. And then we use the degrees of freedom from the residual as indicated in the formula. So we are going to use degrees of freedom from the residual. And last, we multiply that by the SB, which is the standard error for B5. And the standard error for B5, notice there's the general standard error and the standard error for each of the slopes. And the standard error in our case is 0.0165. If you work this equation, you're going to get the same that you got from Excel. The next question says, interpret and test the coefficients, and finally interpret the coefficient of determination and the coefficient of correlation. So let's just interpret the coefficients first. What do I mean by interpret the coefficients? I mean that you have to go back to your regression equation, and you have to let me know what's 19, what's 1.3, what's 0.02, what's 0.035. You have to be able to identify that. The way we interpret the intercept is basically we do try to make all what happens to y if x2, x3, and x5 are equal to 0. So let's just keep in mind that x2 is the number of miles to the closest competitor. If that equals 0, that means that you have your closest competitor right next to you. Then office space available is just this, that there's no offices available. And finally, a median income of 0 means that there's no neighborhoods around the area of the hotel. So the original operating margin is estimated to be 19.3117% for a hotel with those characteristics. That's how we interpret the intercept. And then for each of the slopes, we want to make sure that we leave the remaining variables constant, that we don't change x3 and x5 at the same time that we're interpreting the slope for x2. So for us to continue to interpret the slope for x2, we say, for one additional unit increase in x2, y increase or decrease, depending on a plus or minus here. In this case, it's a plus, so we increase by 1.3004, and that is in the units of y. So what are the units of x2? x2 is miles. So basically, when the closest competitor is one additional mile farther from the hotel, operating margin will increase by 1.304%, while all other variables remain unchanged. And we do the same thing for x3. x3 is the office space available, and it's given in thousands of square footage. So my 1 unit increase becomes a 1,000 square feet increase in office space available. Will have an impact of 0.0219, let me just use the same decimals, percent increase in operating margin, while all other variables remain unchanged. And finally, x5 is about median income, and it's given in hundreds of dollars. So when median income in the area increase by $100, operating margin will increase by 0.035%, while all other variables remain unchanged. Now the question also involved to interpret the coefficient of determination and the coefficient of correlation. So just to make sure we know where to go and look for it, remember the first two are for simple regression only. So we're going to use the adjusted coefficient of correlation as my r squared, and that will be 0.2816. So I interpret it by saying that value, remember, is the SSTR divided by SST. And really what it's saying is the variation, that 28.16% of the variation in operating margin is explained by the variation in our three variables, in our three predictors, which are miles to closest competitor, office space available, and median income. Now the next coefficient is the coefficient of correlation. If we were using simple regression, it would be as simple as looking at this value for multiple r. But we are looking at multiple regression. So we have to go to our original correlation matrix. And remember, we eliminated x1, x4, and x6. So basically the remaining are the coefficient of correlation for x2, x3, and x5. So that's how you indicate it. You indicate it manually, individually, for each of those, and then you analyze it based on the coefficient of correlation diagram that we learned before, that goes from -1 to 1. So in this case, we have the correlation between y and x2 is 0.16. That's a positive weak relationship. 0.5 is a positive moderate relationship. 0.25 is a positive weak relationship. So there is, in general, all of them are positive, so you don't have to specify individually positive, but all of them are positive, and you just indicate which one is weak, which one is moderate, which one is weak again. And finally, the last questions are what we consider kind of our final goal of using the regression model. And it doesn't really mean that all the variables, because there is a relationship between variables, that it is always a causal relationship. But let's just use this example to see how we can use the equation to make predictions. Notice questions number 7, 8, and 9. Basically 7 says predict at certain level the operating margin of one of La Quinta is given certain values for all the independent variables that we started with in the model. Number 8 says estimate at 90% the operating margin of all La Quinta Inns. That's a key. The first one, it was of one of La Quinta Inns. In the number 8 is of all La Quinta Inns. So that means that number 7 will predict only for one hotel. Number 8 will predict the average or the mean of all the hotels. And if we read through number 9, we're going to predict the operating margin of one of La Quinta Inn. So again, we go back to only one. So very basic, we see a difference between 7 and 9 being together with 8, because 7 and 9 are for predicting only one hotel. 8 is to predict the mean. So that's a very simple difference. And we're going to use formulas that are way at the end of your template that are presented on the screen right now. And those formulas, notice that one is for y bar and the other one is for y. And let's not forget that we still have our regression equation. So basically we have 3 formulas that we could use. If you notice, y equals y bar and then y bar equals y hat. Both of them use y hat. So no matter what type of prediction question we have, we're always going to have to get y hat first. The question is, do I stop once I plug in the values in x2, x3, and x5? Or do I have to keep going and use the long equations for each of the questions? So basically y bar is a very simple one. We're always going to use y bar when the question is about predicting all of the subjects, an average, all the hotels in this case, an average of the hotels, the mean of all hotels. That is when we always use y bar. And now the question is, when do we use just y hat and when do you use just the long equation for y? Before we go into that, we need to get my descriptive statistics for all the remaining x variables. Notice that we have only x2, x3, and x5. So let's go back to our data and get descriptive statistics. So I'm going to go back up to my data. And I'm going to go into data analysis, click on descriptive statistics. I'm going to select my input range, which is just going to be the x's. So I start on miles, Control Shift right and down. I have labels in the first row. My output, let me just go down. We have a lot of outputs, so let's just put it all the way to the end. Summary statistics, we can just leave it there. And notice it computes the output for 3 tables, 1 for miles, 2 for office, 3 for income. But we're going to focus right now on 3 pieces of information. What we call the sample range. And for miles, my sample range goes from 0.1 to 4.2 miles. So it's between the minimum and the maximum. Office space, my sample range goes from 140,000 square feet to 875,000 square feet. And notice that the data for office space is given in thousands of dollars. So you need to use thousands of dollars and convert it to the same units as the data. And finally, the last one is income. And in my data, what we call within the sample range of my data, the sample range is from $28,000 to $46,000. So basically, the rule to either use just y hat or y is if all the given values for x are within the sample range, then we're just going to use y hat. But if at least one of them is not within the sample range, then I need to use the y equation. So let's read carefully number 7 and analyze it. It says we want to predict the operating margin for one of the Quinta Inns with the following characteristics. 2,590 motel and hotel rooms within 3 miles. Now, one thing is we eliminated that variable, right? So basically it would be like not having that information. You don't need it. Then it says 5 miles away to the closest competition. 5 is part of my variable, so I need to go and say yes, I'm going to use x2 equals 5. And then the next one is x3, which is 750,000 square feet. Now remember again, the square feet is, of office space is given in thousands. So we need to just use 750. And we need to come and verify if 750 and 5 are within my sample range. Oops! The first variable, 5, is not within the sample range. It's outside the sample range. So with only one variable being outside the sample range, I know I must use more than just the y hat. I need to go all the way to the lone equation. And then I'm going to use 750 because it was 750,000, but I'm going to transfer that in here. And then the last variable that they're giving me is, let me see, 18,000 college and university enrollment in nearby colleges and universities. That again is not part of my model right now, so it would be like ignoring that piece of information. Median household income of $35,000. So we're going to use 350 because it's in hundreds of dollars, so we just eliminate 100 and that would be 350. And then 10 miles away from downtown, that's still another one that we don't use because we eliminated that variable. So when I put it all together into my template, you have to start by indicating which numbers you're going to use inside your equation. And then bring your equation, your y hat, because that's always going to be the heart of any of the predictions. And instead of x2, we're going to replace with 5. Then x3, we're going to replace with 750. Never use just 750,000. You have to use the same units as the data. And then 350 for the income level in hundreds of dollars. When you solve for this equation, your total is 54.446. That would be the answer if all the variables, all the given values, those are called given values, like this is x2g, x3g, and x5g. All the given values are within the sample range, but we notice that 5 is not within the sample range, and that's good enough to tell me that I need to use the lone equation. We start by plugging in the value of y hat, and then we use t inverse of alpha halves times 2 because we just said that we use times 2 every time we have a t in front of a plus minus. That means that it is a one-tail, so that's why we have to multiply by 2. And then we use the degrees of freedom from the residual. So go back to your ANOVA table, get your degrees of freedom from there. And then it says times SE. Remember when we said what is SE? We said SE is the standard error from the summary output, so make sure you use the correct output in regression. And my SE for this will be 6.57. So times 6.57 times 1, the square root of 1 plus 1 divided by n. If you remember, we had 100 data, plus x1g, that's the given value for x1, or in our case we start at x2, so that would be 5, minus the average of x2. But remember, we already got descriptive statistics for each of the variables. So the average of x2 is given there as 2.31. So just replace that by 2.31 divided by 100 times the variance for x2. Again, we have descriptive statistics, and it says that the sample variance for that is 0.7843. So we use that in our equation, 0.7843, and we follow the same formula for the remaining of the variables. So we have really 3 variables, and we're going to repeat these again, but we're going to change the values. Now it's not 5, x3 is 750, the given value. The average for x3 is, I go to the mean of x3, and that's 492.23. minus 492.23 divided by n minus 1 times the variance for x3. And the variance for x3 would be 27,440. So let me go and change that. 27,440.74. And we do the same for our last variable. So we need to include a last variable, which is x5. The given value for x5 is what they're asking us to use for prediction, 35,000. The mean for income, we have to go back to income, descriptive statistics, and my mean is 362.2. So I go into 362.2, and minus 1 is the same, and we need to replace my variance for variable number 5, which I can find also my descriptive statistics for variable 5. That will be my sample variance, and I usually just do 4 decimals, 1,645. So I'm going to place that here, 0.6162. And that would be my formula for getting the interval. As you can tell, because it has a plus minus, it's going to be an interval. It's not just going to be a value. So let's work on that and see what the results are. When you work it out, either in Excel or in the calculator, you get that the low, let me just put a little more information just in case you can verify your results. I get 54.446 plus minus the value of t is 1.713 times the standard error times the square root is 1.062. Doing all decimals in Excel, I get that my confidence interval will be between 42.49 and 66.40. So basically, we know that one hotel with 5 miles away from the closest competitor, 750,000 square foot in office space, and 35,000 median income in the area will have an expected average operating margin of 42.49% to 66.40%. Now we go to the next question, and the next question is all La Quinta in, so there's no question about that. It's always going to be the lone y bar equation, and we're still going to eliminate, we're going to eliminate the variables that are not part of my model. We keep x2, we keep x3, we eliminate x4, x5 remains, and x6 is eliminated. So basically we go back to our template and we fill out the information. We're computing a 90% confidence. x1 is not in the model anymore. x2 is 3 miles away. x3 is 300,000 square foot, so we just use 300. The median household income is 40,000, so we just use 40. Oh, x4 we eliminated x4, and x5 is 40, x6 we eliminated. So we start by using my regression equation again, because that's part of the lone equation here too. Instead of x2 we replace that with 3. Instead of x3 we replace that with 300. Instead of x5 we replace that with 40, and we get our y bar being y hat being 31.17. And now we use the y bar equation. Y hat is 31.17. Our t equation is t inverse of alpha, which is what is alpha here? Let me just verify. 0.1. Oops, that's my equation. Alpha is 0.10 divided by 2 times 2 comma degrees of freedom from the residual 96 times the standard error, which is 6.57, and we follow the same as before. So I'm just going to go back here and copy, since the means and the variances are the same. Now there's one little change here. We do not have a 1 plus. We just do 1 divided by n. Oops. 1 divided by n, and then given value of x2 is 3, given value of x3 is 300, and then the given value of, oops, what am I doing here? The given value for x5 is 400, really, because it's not 40, it's 400. It's not given in thousands of dollars. It's given in hundreds of dollars. So when we process this equation into your calculators or using Excel, we should get, made a mistake, y hat is 43.755. So make sure that you correct that in your, is 43.755. And then after all that, I get 43.755 plus minus, oops, let me see one thing. You verify that I'm doing my computations right. Plus minus 1.661 t times the standard error times the square root, and this is gonna give me a 41.61% to 45.90% in as my average percentage. And finally, the last one, let me just delete this. The last one is estimate with 94% confidence the margin of one of the hotels, so we know it's either Y hat or Y. And we check each of the values within the sample range of my data. So I just verify where my descriptive statistics is, and 3.5 is within the sample range, so that we're good there. 250 is within the sample range, and finally 420 is within the sample range. So all of them must be within the sample range for us to just use Y hat and replace the values here. So x2 is 3.5, x3 is 250, and x5 is 420, for a result of 44.01%. And that will be your answer.